There's one more special method we're going to talk about. It's called the toString method. Okay. Every object in Java has this toString method, and it has a default return of the string's value representing the object's hash code in hexadecimal. That's a lot of information that I wanted to tell you in case you wanted to know. You don't need to remember it. But basically, it's just a representation of the object, like a computer representation of the object. But we can override it to return important information about our object. Like maybe we want to know specific information about our object. Now the coolest thing about toString, which is why it's important, is we call it in a special way. All we need to do is write the identifier of our object, and the string from toString will be returned. Okay? So this information was what I was doing over here. So I created Billy and Kelly. I'm going to take out all of these calls. I created Billy and Kelly over here. Now, I wanted to call their toString. At this moment, I have not overridden it. It's just the one that's given to us from the object class. We'll talk more about polymorphism later, but basically, it's just the one that's given to us by Java. Okay? So when I run this, I'm going to get some code. And I'm going to expect it to be different from Billy than it is for Kelly, because Billy and Kelly are two different students. So you can see down here. So I printed them out. And I can see that this is a representation for Billy. This is a representation for Kelly. They're two different representations because they're two different objects. Now, what would happen if I wrote system.out.println Billy again? I would assume that I would get the same answer, right? Because Billy and Billy are the same. So I'm going to run it again, and I would assume that Billy and Billy would match. So let's test that. Here we are. Billy matches Billy over here. So that's saying, hey, these are the same objects. Okay. So here is the slide of what we just did. But like, let's say I don't really care about that code. I want some information. How can I override that? Well, what you need to know is that you need to do it in this very specific way. So I'm going to say public string toString. If you're going to override this toString method and you want to call it in a special way by just using the identifier, the name of your object, Billy or Kelly, you need to make sure that this header is exactly the same. And then I'm going to return, I have to return a string. So I'm going to start my string. Maybe I'll say student name. Student ID. I'm going to want to put a space here, I think. And so it's going to give me the ID num and student GPA. Okay, so now if I've done it correctly, all this stuff should be returned. Hopefully, let me check. You got a space here, a space here, I have a space here, I have a space here. It's formatted nicely. So now, when I run this information, what happens? All right, let's see if it works. I should get more specific information about Billy and Kelly. It says student name Billy, student ID A123, student GPA 3.9, student name Kelly, student ID B123, student GPA 4.0. So this is a nice way that we can represent our objects data, or we can give our objects information using the toString. We have one more special method, and this is called the main method. You can see my main method is right here. You will need to memorize this, and you will be tested on it, just because it's the most important method, because it's what tells the computer to make the program run. Usually, it's located in the client, the main, or the driver class. It's also, it's where all the work is carried out. So this tells the computer to go. It's where we create our objects. And like I said, not always true. Sometimes we'll create our objects elsewhere, but it's where it tells the computer, hey, go, do what I asked you to do. Call the methods, create the objects. It uses the classes to complete the tasks. So this is never going to change. It's always going to be the same method. You're going to write public static void main string args. That's the declaration. And then anything you want to do that you want the computer to do is going to go right here inside these braces. Now, another cool thing here from IntelliJ, this right here, it says run student main. It finds where the main method is. You can click on it and it'll run the program for you because it knows this is where I need to start the computer. Okay, so now we're going to sum everything up. What's a program? Big picture. It's a collection of instructions that when we do them, they perform a task. In this case, we made a couple students and we printed out their information. So this word compiling, we're going to talk about it a lot. In this case, what is compiling? Well, this IntelliJ usually does compiling and running all at once. So what am I going to do? I'm going to actually create an error here. This thing is actually compiling it for me. It's telling me where my error is. But let's say I want to run it. It's going to tell me, I'm going to get an error here. Compilation failed, probably. Oh, it gave me the error right away. So it's saying, hey, you didn't put a semicolon. Can't go on. Here in line 8. So I'm going to double click it, put my semicolon in, and now that error went away. So compiling is just checking for errors in my code. Okay? When I run the program, not only does it check for compile time errors, so things that I miss like this, it also checks for runtime errors. We'll talk about runtime errors later. We also want to talk about comments. Now, I've been telling you to comment with your name, but then I realized I didn't really give you a full explanation of what commenting is. They help make programs more readable. I want your name at the top, so maybe I'll put Mrs. Keith here. Okay? They help others reuse and revise your code because it will tell you, hey, what does this method do? Okay? They're not read by the compiler, so the compiler skips right over them. There's two ways to do it. We can use \* and *\\, and that will give us many lines of code. So let's say I have to remember to close it out though. Mrs. Keats program. Oh, it closed it out for me. See, it closed it out right here so that I didn't have the whole rest of my code commented out because I don't want that. I want the rest of it to be fine. So that's multiple lines. And then there's also another style here. \\, which gives me one line. So it ends at the end of the line. I like to use it a lot because it's easy. So here I wrote student instance variables. Tell people this are the instance variables. Here are the constructors. Here are the methods. And maybe I want to say this method prints out how many hours a student studies. So if somebody else comes and uses my code, because we're going to work together. Usually we're doing different pieces of code and we need them to fit together. So if I want somebody to understand how my code works or what my intent was or what the logic is, I'm going to just put a quick comment there to let them know. Okay. We also, when we're doing classes, it's a good idea to just kind of organize your thoughts. So this is a really easy way to do it. It's called a UML diagram. It's a map showing what your code's going to be. Usually you have your class name at the top here. You have your attributes, which are the nouns in the class. And then you have your methods, which are the verbs. Another word for attributes would be data or instance variables or fields, like class fields. Those are all different information we use or words that we use for attributes. So I'm going to take a problem. Maybe I want to set it up using a UML diagram. What does that look like? Okay. So I say, all right, here's my problem. A checking account has an account number and a balance. It can withdraw money, deposit money, return the current balance, and return the account number it is associated with. What does that look like in a UML diagram? Well, first, I have to figure out what are my nouns, what are my verbs. Okay? So I'm going to go through my problem again. A checking account has an account number. That's a noun. And a balance. That's another noun. So these are the things it has. These are its attributes or its instance variables. So what can it do? It allows an account holder to withdraw money. It allows an account member to deposit money. It also allows the account number, it also allows the person using the account to return the current balance and return the account number it is associated with. So you can see the verbs or the methods, they're going to become the methods. They're in red, and our instance variables are in green. So how do we set it up? I would even write it like this. Let's see. Maybe I will write this as data. So checking account, these are my data, and these are my methods. Okay? Account number, balance, and I've created some names for methods: deposit, withdraw, get balance, get account number. And I don't need to do anything else. This is just kind of a map of where I'm going. So, just to remember, classes are a blueprint. They're written by a program as part of by a programmer as part of a programmer. They don't exist when programs execute, except when we create objects. So they're only existing as instances of that class. You can't alter its code during a program execution, and its name is a class name. An object has to belong to some class. It exists during the time that a program executes, but it doesn't exist before, and it doesn't exist after, just during the execution. It has to be explicitly declared and constructed by the program. Remember, we did this here. This is the two-step process. This is the one-step process in the main method. Okay? It has attributes that can change in value, so it has things that can change, and methods that can execute during a program. Here in the blueprint class, these were my attributes here, and these down here were my methods. All of these. And they're often referenced using a variable name. Our variable name here was Billy with a lowercase b and Kelly with a lowercase k. So that's pretty much it. This is the big meat of object-oriented programming. How is this different from the class that you took last year maybe? Or how is this different than line-by-line coding? This is how it's different. We're creating different instances of classes that can interact with each other.